Anyone need this again? You need a copy of this. I don't think I need one. And you don't need one. Okay. Wait, what is it? The final exam. For number 42, we have to do the same thing we did for 40, except now we also have to find the slope. So for this, we're going to go ahead and find the slope of these points, do -2 minus 2 over 2 minus 3. Subtract those to get -4 over -1. And that would simplify to be +4. Then once we have our slope, we need to find our actual equation. So using our point slope formula, I know we have this written already, I'm just going to rewrite it. Does not matter which order pair we use, we just have to choose one of them. I'm going to use the first one since everything is positive, so I wouldn't have to change anything. So this would be y minus 2 equals 4, and then in parentheses, x minus 3. And then we could distribute. So y minus 2 equals 4x minus 12. And then add 2 to both sides to get y by itself. So y equals 4x minus 10 would be our final answer. Do we have any questions on that one or any other questions on this page in general? Remember that if you are taking the final exam, especially seniors, as yours is first before everyone else's, you should be writing this stuff down. On the next page.
Wait, don't give that to them.
Probably.
Okay.
Do you want to go do that now, Evan?
Alright.
Do you want to go do that now?
Yeah.
Here, take this. Or the attendance office. I don't know. They might tell you something.
Thank you.
We're going to start at number 43 for this graphing section. If it's in standard form, we need to convert it. So converting it by moving our x term to the right. So we have -2y equals -3x minus 4. And then divide everything by -2. So our new equation would be y equals +3 over 2x plus 2. And then you would start at your y-intercept of 2. Your slope is 3 over 2, so go up 3 to the right 2 as many times as possible, and down 3 to the left 2 as many times as possible. And then connect your points. Make sure your lines have arrows. You will have access to your calculators and rulers if needed. Do we have any questions on 43? We're just going to do a couple more of the graphing ones. Skipping down to 47. Remember that anytime you see something that's x equals a number or y equals a number, you should be writing koi bucks somewhere near it so that you remember what those stand for and how to graph this. This is an x equals, that means it's going to be a vertical line. So when x is -3, that's going to be a vertical line along that point. Questions on that? For 48, this has an x and a y, so our y-intercept is going to start at -2. Our slope is -1, so we're going to go up 1 to the left 1 as many times as possible. And down 1 to the right 1 as many times as possible. Remember that down and left are both negatives, but we can't have them together, otherwise that's a positive. That one's not straight. Do we have any questions on that one? Or other questions on this page, or want to see any others on this page? On the next page, this is the last objective in Unit 2A. Intercepts. So the first section is finding intercepts from a graph. Wherever this line crosses the x and y axis would be your x and y intercepts. So here and here. And you would write those as ordered pairs. So for your y-intercept, that would be the point 0, 2. And for your x-intercept, that would be the point 3, 0.
Is that it?
Mm-hmm. For 50, this has a y-intercept, but it does not have an x-intercept. So for our y-intercept, we would say 0, 6. For our x-intercept, we would say none and a, doesn't exist, any of those. What we cannot say is 0, because that would mean there's an x-intercept at 0, and that is not the case. Questions on those two? We're going to do one of the algebraic ones. Good morning. I don't know if you're here when I do those up. For number 55, we now have an equation. We're still trying to find our x and y intercepts algebraically. In order to do this, I'm going to show you one way of doing it fully and then one way kind of doing some shortcuts. So if I'm looking for my y-intercept, I need to put 0 in for x. And then start to solve from there. So -3 times 0 would just be 0. this would just end up being negative 9y equals 36, and I could divide both sides by negative 9. So that would be the order pair. X was 0, y is negative 4, so 0, negative 4. Then to find our x-intercept, I'm going to skip a couple steps. If you, yeah.
So for 9y, do you subtract or add when you're taking 9 out?
You're talking about here?
Yeah.
Or dividing.
Oh, okay.
For x, if you know that you're putting 0 in, you don't have to do this work. You could skip to this one. So if I'm putting 0 in for y, I could skip to negative 3x equals 36. Because I know if I put 0 in for y, that would become 0, that term would disappear. And then I could just divide. So that would be the point negative 12, and my y is 0. So those would be my x and y intercepts. Do we have any other questions on that one? Ricky, this is like on the 3rd or 4th page. Are there any others on this page we want to see or go over or have questions about? On to the next page. So this is starting your unit 2B. I know we just did parallel and perpendicular lines, so hopefully this isn't that new or that old in your memory. For this first section, we just have to find the slope that is parallel to each given line. So for 57, we need to know what the slope of this line would be. 5 wouldn't be the slope. If this is an x equals, this is a vertical line, so the slope is undefined. And if it's parallel, I think I wrote this on the answer key, but you can write this also. If it's parallel, they have to have the same slope. So if this is undefined, the slope that is parallel would also be undefined. Questions on that one? For the next section, you're trying to find a slope that is perpendicular. Remember that perpendicular slopes have negative reciprocals. So if one slope is positive, you would take that, flip it, and make it negative for the other one, or vice versa. So for 62, I'm going to write my blue box one more time. If I know the slope of this line is undefined, the negative reciprocal of that, even though it's not negative, is 0, no matter what. We have to remember that 0 and undefined are perpendicular slopes. Questions on that one? For number 65, we are now going back and writing our slope-intercept form of this, so we need our point-slope formula one more time. given a point, we are given an equation, and we have to find an equation that is parallel to the one that's given. So this is an x equals, and as we were just doing, the slope of this line is going to be undefined. If it is parallel, it's going to be the same. We will have an undefined slope. With these type of problems, we can't use the point slope formula because we can't put undefined in as the slope. It wouldn't work out. So we have to know that if it's undefined, we're using an x equals, and we have to look at what our x value is, which is 5. So our equation would be x equals 5. The problems like these, you really don't have work to do except know this information. Now, if it were the opposite and said y equals 0, then we could find that the slope would be 0, and then we could use our point slope or do the same thing. But with undefined slope, we can't put that in. We have to know what that is. Do we have any questions on 65? $67 is similar, except now we need it to be perpendicular to this. I'm going to write 4 bucks one more time. If this is a y equals, the slope of this line is 0. But we need something that's perpendicular to that. So if it's perpendicular, the opposite would be undefined. And again, if it's undefined, that would be an x equals. So we look at what our x value is and write that as an equation. So x equals -3 would be our final answer there. Do we have any questions on 67? Or other questions on this page in general that we want to see, go over, have questions about?
Did you do, like, one of the actual problems from the parallel and the perpendicular at the top, like 63 or 64, and like, or like 69, 68, just one of each?
Sorry, you said so many numbers. You said 63 or 64, and
Yeah,
then what were the other ones?
Just one from the section above, the parallel stuff.
Pick one.
60.
For 60, this is not in slope-intercept form, so we have to get that in slope-intercept form first. Subtract 3x on both sides. So 2y equals -3x plus 4. And then divide everything by 2. So y equals -3 over 2x plus 2. If we're looking for a slope that is parallel to that one, what would your slope be? -3 over 2. Questions on that one? For 68, same thing. Get rid of your x term by moving it by subtracting. So we have 3y equals -8x minus 9. Divide everything by 3. So our equation for this, and I'm going to space, y equals -8 over 3x minus 3. And if we need a slope that is perpendicular to this, what would it be? 3's. questions on that one? Any other questions we want to go over or have questions about on this page? On the next page. Your linear regression, so if you don't have your calculator, you need one, go grab it. The 69 that's on here was a typo, ignore that. So we're going to do 72. I got it. I don't know what those are. I just got in. Okay. For these problems, they found the line of best fit on this, but it did not say how many decimal points to round to when finding the line of best fit. So we are going to kind of redo it. First, anytime you're dealing with years, you have to change the first year to 0 no matter what. And then every year after that is how many years has it been since. So from 2001 to 2006 it's been 5. 2001 to 2007 it's been 6. 2001 to 2009 it's been 8. 2001 to 2011 has been 10, and then to 13 has been 12. So instead of the actual years themselves, we're going to put in 0, 5, 6, 8, 10, 12. So in your calculator, you're going to go into Stat, next to the arrows, and then go into Edit, and start putting in those numbers in L1 and L2. If you have numbers in your L1 and L2, go up to the top, hit clear, not delete, but clear, and then scroll back down, and they should clear it out. So in L1, you're going to put in the 0, 5, 6, all of those numbers. And in L2, you'll put in the amounts of marriage licenses. You're gonna be after, yeah. After you have all of your data in, we're gonna go back into Stat. and then scroll to the right until you're on calculate. And then either hit or scroll down to number 4, linear regression. And because this is asking about certain years, like we're going to input data, we want to store this. So go down to store regression equation and hit alpha trace. And then hit enter 3 times. And you should get this equation. Where are you at? Go back to stat, scroll over to calc, and number 4. And then go back to stat, scroll over to calc, hit number 4. Go down to store regression equation, alpha trace, enter 3 times. This equation is different than the one that's given because they use the actual years and not the numbers we put in. And also, we are going to use more decimals than they did. So we're going to write this down and up to 3 decimals. More than that is great. Less is probably less accurate. So at least 3 is good, and then we can round. So negative 3,992.683. And then to answer part A, we need to know how many years has it been from 2001 to 2005. And that's been 4 years. So on our calculator, we're going to store 4 as x. So if you're still on the screen, I'm just going to hit 4. And then this STO above on. And then x, and then enter. And then I'm going to go back and grab the equation that I stored in my y1. So alpha trace. Wherever you stored yours, hit enter on that one. And then enter one more time. And this says round to the nearest 100. 100, not 100. So 130,000 100. If you are looking at the answer key, you'll see 2 different answers. One is us putting it into our equation, and the other is using this equation because it doesn't say what to round the original to. Both are technically correct. One is just more accurate. Then we do the same thing for part B. In 2021, that would be 20 years from the original. So we're going to now do the same thing, but put 20 in. So we're going to put 20, the STO, and store that for X, and hit enter. And then go back and grab my Y1 from alpha trace, and hit enter again. This one also says round to the nearest 100. So 66,246 or 200. you can use the pink sheets that have these steps when we get to the finals if you need it. Do we have any questions on this problem? Or want to see any others? On the next page, this is the last section in 2B, or in Unit 2B, your word problems. So I only have one circle, but if you want to go over any others, that's fine. With these, find what's important, find what you are being asked to find, be able to set up an equation and solve. So in this, important things, we have $17.25 per hour, in addition to a $35 deposit. And then we have to find the total cost. This should say from this time to this time. So the thing we don't know is the total cost. I'm going to label everything as a variable, and that may help you kind of set all of these up. Total cost is usually like our y. All of these will be set up in some sort of y equals mx plus b format. So y would be like our total cost. Our m would be anything where it says per, for each. So in this case, the per hour. This would be the cost per hour. Our x would be the number of hours. And then our b would be the deposit, or initial deposit. So knowing all those things, we could start to put numbers to variables. We don't know our total cost, so that's going to stay y. Our cost per hour is $17.25. Bless you. Our number of hours would be, we have to count from 9:30 to 2:30, so it's 10:30, 11:30, 12:30, 1:30, 2:35. And then our B, our initial deposit, would be that 35, so we are adding 35. So then from there, we just have to put all that in the calculator and figure out what our y value is. $125 because we're looking for total cost. You're gonna be after Carter. Do we have any questions on 73? Or any questions on other questions that we want to see go over on this page in general? If not, we can move on to the next page. So now we're in Unit 3, Systems. First objective was solving by graphing. So we're just going to do a couple of these. Remember that these can have the same type of solutions as the solving regular equations. So 1, none, or infinitely many. For number 80, we have to graph both of these. Again, if, when we originally did this, if you did it in different colors or different writing utensils, it could help me see better. But either way, for this first one, that would start at -1 and go up 3 to the right 2 as many times as possible, and down 3 to the left 2 as many times as possible. That was. Then for this other one, this would start at +3, go up 3 to the right 2, or down 3 to the left 2. These two lines do not intersect at all. They have the same slope. These lines are parallel, so the solution is none. They will never intersect. Do we have any questions on that one? If we had something like 81, we would need to solve both of these, get them both in slope-intercept form. So I'm going to kind of do them simultaneously. Subtract 5x from the first one, subtract x from the second one. So -y equals -5x minus 3. And y equals -x minus 3. Second one is solved. The first one, we still need to get rid of this negative by dividing everything by -1. So y equals 5x plus 3. And then we can graph both. These do not have the same slope, so I know it's not going to be no solution. They're also not identical, so I know it's not going to be infinitely many. So for this one, this will start at -3, slope of -1, so up 1 to the left 1 as many times as possible. The other one would start at 3, and the slope is 5, so I can go up 5 to the right 1 or down 5 to the left 1. And wherever they intersect would be your solution. So here they intersect at -1, -2. And that solution point needs to be in an ordered pair. Do you have any questions on that one? Or any other questions that we want to go over or see on this page? We'll do this one. I don't think we'll have time for the second one. So for the second objective, that's solving systems by substitution. If you have an equation where it's already solved, like one of them is already solved for x or y, you're going to take that equation, put it into the other one, where that variable is. So -2x plus 3 times, in parentheses, put this equation, -3x plus 21, and then equals -14. Then you could start solving for x. -2x minus 9x plus 93. 63? That was too much. Then solve for x, so combine your like terms, and you can move things at the same time. 77. And divide. Once you have x, you can put it back in and find your y. So I'm going to put it into the one that solved for y. Negative 3 times 7 plus 21. So negative 21 plus 21. These will cancel, just become 0. Your final thing, you need to put these together in an ordered pair. X would come first, so 7 and then 0. So we'll do 88, I think is the other one I have circled. Tomorrow. Do we have any questions on this one though? So we'll continue this tomorrow. Remember that if you are working on this on your own, come see me after school, not today, but tomorrow or in the morning before class. This morning should have been a morning you could have come to me, but that did not happen. If you need to finish a test or retake a test, come see me in the morning or tomorrow after school as soon as possible.